Hi guys, just before we start today's video, I just want to show you something. So this is from a repair I did about a week or so ago with the 1500 watt PA system and the outdoor speakers. And I know a lot of you guys were interested to know, and I know you watched this video, a lot of you, where that PA system is actually used. So I was down there yesterday looking at another small job, and I just made a little bit video, 30 seconds. So before we start today's video, I will just show you where that PA system is actually used, and then maybe you can have some more thoughts of how the corrosion got into the amplifier. Okay, here we go, and then on with today's video.
Well done to Lee, who's only 4 years old. Well done, Lee. Well done to Jack. Unlucky Jack. I'll let you in the bingo tonight, then you'll be alright. Well done to Flynn, who comes second. Can you give Flynn a round of applause? Well done, Flynn.
Hi guys, welcome to another Learning Electronics repair video. This is more electrical than electronic really. This belongs to my wife. Apparently she used it for flattening clothes. And about, I don't know, a week or so ago, I'd come to the office, I'd left a video rendering on my computer, and it was one of the long ones I did, like the 2 hours odd, a couple of weeks ago maybe, and she phoned me at the office and said, the power's gone off. I said, oh, she says, well, and your computer was still on, I think. I said, oh yeah, it was rendering a video, but it might be finished by now. She says, it wasn't really my fault, I unplugged the iron, I've been ironing with this, and says there was like a flash when I took this out of the socket. So of course I got home and I found that my video file, about 23 gigabytes of it, was corrupt. So I pointed out the error of her ways. No, really, I'm nice to Julie, my wife Julie. Having pointed out the error of her ways and having to render the video again, which took another hour and a half, and only to find as it was about a few hundred megabytes bigger than the file that was corrupted, so the thing had almost finished. I said to her, well, you should have unplugged it later. So anyway, for my cheek, I've been asked if I can fix it. Otherwise, she says you'll have to buy a new one, because I won't have any flat clothes. Which actually, I was wondering why my wardrobe's looking a lot emptier than usual. So, my first thoughts was have a look on YouTube and see how to fix these. Do you know what? I can't find, I didn't thoroughly look, but I had a look. The only videos I can find on fixing these are not in English. Which, I mean, fair enough. I mean, you know, we all have our languages to speak. You know, why should we say English is better than any other? Yeah, but they're either not in English, or even more annoying to the point of pointlessness, as far as I'm concerned. Nobody speaks; they just show you how to do it with music playing. That annoys me, guys. That really annoys me. If I'm trying to find an instructional video and there's several, if I click on one of those not speaking or they're playing music, I just come straight back off it. And the only time I'll ever watch that video is if I can't find any of them which they're speaking. Preferably in English, but you know. And just another thing on instructional videos where they don't say anything. I mean, even like, you know, cavemen in like prehistoric times had developed language, yeah, because like language is like a kind of like useful thing, yeah. So what is it that people in the 2020s think that in actual fact we're far off better by playing music and just doing it than actually speaking? Yeah, is this a regression back to earlier societies where before they could speak, they were just stuck there hitting sticks together and banging drums? Yeah. Comments below, guys. There we go. So I'm now going to correct a couple of things. Hopefully I'm going to fix this for my wife, so I can have some flat clothes again. And hopefully this will be the first YouTube repair video of an iron in English. I mean, come on, why? It's like only certain nationalities are able to do this sort of work. I don't know. Anyway, I'm sure we can have a go. Little rant, quiet rant, yeah. We should start a video in a happier mood, don't you think? So the first thought I had is, where did the flash come from when you unplugged it? You said from here when you unpulled the plug. So my first thought is there was something like wrong with the cable down here. And it's not, I mean, it looks fine. I mean, obviously damaged cables where they go into the plug is the most likely case. And it's fairly flexible until you get to this point here, which is like really as hard, it won't straighten there, you see it. So there could be a problem in the cable here, which would make me think, well, that'll be a short. So first thing, I'll just grab this meter, guys. I thought the flick could just come out occasionally, rather than the Kai, which I do like. So we basically have an open circuit here. There's no on-off switch on this thing. You know, that's something. That's apparently not an on-off switch. There's a dial. I can turn the dial minimum, maximum, and I don't get anything here. Yeah, it's not conducting. Let's go into ohms range in case it has some resistance. So that's my fingers across it. My fingers measure minus 500 meg. It's pretty impressive, isn't it? I'm obviously feeling negative today, hence that intro, yeah. And you can see that doesn't change, yeah. I still have a negative resistance. Why is that, by the way? Now I have a positive resistance. Okay, what do you figure that one out? That's the first mystery for the day. How come I now have a positive resistance, but if I do that, will it do it again? Oh, obviously my negative attitude has passed, guys. Okay. Comments. So it's like it's open circuit basically, and I'll just try that again and waggle around that bit of wire where it's like I can't sort of straighten it out. This bit here. Let's see. Oh, nothing's really changing. So it's like something's open circuit on this, and unless it's the heating element, you'd think it must be something that's fairly easy to fix. So we can see coming in here we have green and yellow, which is the earth wire. We have brown coming from the wire coming in, and we have blue, live and neutral, even though our plug's going either way around. Let's have a look. So we can go from here. I will go to continuity. Let's have a look. So nothing there. Okay, we have a connection to the neutral, the blue one, yeah. And from here, must go to the brown one. Yeah, and none of them should go to the green. Should be open circuit. Yeah. Even when we waggle this bit of wire, which is a little bit stiff. Yeah. So we don't seem to have any shorts to earth, ground. Oh, we waggle this thing. So the wires coming in are okay. Then this is here, so we can forget this. We have a red and a blue which disappear up into the handle, and a black. So they all disappear into the handle down there, yeah. And the black one actually goes to here. Okay, so the red and the blue are effectively just connected directly to the brown and the blue where we just measured. So they're reading, let's have a look. Open circuit, I'm sure. Yeah. Did it actually read anything without my fingers on them? About 4 mega ohms, yeah. And then we have a black one, which to the brown one reads the same, about 4 meg. Oh, and to the blue one reads 23 ohms. So that looks like that's the resistance of the heating element. Oh yeah, also connected here we've got another one blue and black as well. And then we've got 2 red wires going down here. Where do they go to? It's not like we've got a lot of wires going to not many places in here, by the looks of it. Let's take this a couple of screws out of here. Yeah. Oh, talking of screws, by the way, this came out of it. Let me show you. You've probably seen them before. This thing, like an Isle of Man Phillips screw, yeah? Obviously made on the Isle of Man, this thing. If you don't understand that, go and Google Isle of Man and you'll figure it, yeah? What's the point of that? Because all you do is you stick an Isle of Man screwdriver into it and you just unscrew it the same. And this is like just a cheapo magnetic screwdriver with like a handful of, you know, all these bits that I paid like €6 for it. It was like €6, so it's not like these are high-tech secret things that you can't get. So what's the point of the Isle of Man screw? Yeah, that's comments below. Yeah, comments. Okay. So anyway, I digress, because the other screws appear to be like effectively like the ones with 4 things in, yeah, Phillips or Posi drive. So let's have a look. Still using my €6 screwdriver set. Let's figure out where all these wires actually go into. Why is there so many wires? I mean, surely this is like power comes in, goes to a thermostat, to the heater, and then back to power effectively. You know, that's what it is, I would have thought. This dial somehow controls it, so I guess there's wires going to that. Or there might be mechanical. I mean, it's possible the thermostat is like a bendy metal strip, and that effectively alters the position up and down to set the temperature at which the thermostat actually reacts. It might not be electrical as such. Okay, so let's see. I'm doing some extra talking on this video, guys, by the way, to prove my point about what's the point of instructional videos where people don't talk. I just don't get it. Right, okay, so what do we have? Well, this red and black go to like a little orange thing in here, yeah? Which might be a water level thing, I don't know. And then they disappear into the bottom of it, yeah? The blue and black disappear into the bottom of it, yeah? And then this red, blue and black go into the top of it. Oh, I see, there's like a button here which probably squirts water. Now that sounds mechanical, I can hear a noise going, yeah? Okay. Let's figure out what all these wires do. I'm pretty confident this one's going to be the heating element, the blue and black. I'll probably have to zoom it out a bit so you can see what I'm doing. Yeah, that's probably a bit more visible, isn't it? So you can see now the red and blue and black disappear into the handle. These are like, obviously, heat resistance wires. This must be the heating element. Ground, and then these disappear into an orange thing here, which might be something to do with the water. So the blue and black have got to be the heating element, and I'm sure it's reading like 20 odd ohms. Yeah, 24 ohms. So I don't think we have an open circuit heating element on here. So why am I not getting any connection from here? That's the question. Well, the blue coming in goes to the blue here, so whatever the problem is somewhere between the black wire coming back from the heating element here and the brown, and that disappears up into the top here. So we need to figure out how to get into here and have a look to see what is there, yeah? Because we've got to be clear, we already have from the blue wire coming in to this black wire 23 ohms. So whatever's going on the bottom of there, it's not open circuit. And I'd expect, yeah, 24 ohms. That sounds reasonable. Okay, so how do we get into the top of it? Well, guys, this is proven to be really difficult. I mean, I've damaged the plastic a bit to get this piece off, and for the life of me, I just can't get it to come off. I've shone a torch down there to see what's holding it. I can get it up so far. I thought under this rubbery thing there might be a screw, but when we take the torch and we shine it down inside here, I don't know if you can see it very well, but there isn't. But what we do have is a PCB in here. and this connects to the red, blue and black wires. And I think I can lift this up far enough. This is held on with clips, which will clip back in. That's not a problem. I can probably actually get the PCB to come out. I don't think there's anything else in here that we're really interested in. Yeah, so if I feed these wires in, this PCB I'm pretty sure will come out of here. It might be held with a screw, but I can possibly get at it just in there. So let's see if I can get the PCB out of it, and then we can see what we've got. Well, with a bit of effort, and I managed to bend the plastic enough to get the screw out, and I've now got the PCB out. Well, I'm not sure that this is actually going to help me very much, because it's all kind of like filled in with nasty black stuff. We have a relay here. I can see a relay. We have something with a couple of little balls in, which I'm guessing is some sort of motion sensor by the looks of it. Yeah, I guess that's some sort of motion sensor. A diode, I can see a diode. No, it's a resistor actually. Let's zoom down a bit. We can see it a bit easier now. So yeah, there's a thing with two little balls in, as I mentioned, which I'm guessing is some sort of motion detector. Although I'm not exactly sure how it works. Capacitor, this is not a diode, it's a resistor. We can see the end of it, a relay. Something there, but it's kind of like all sealed into this stuff. I don't know whether there's anything else under it or not. I'm guessing there's obviously something that controls the relay. What's it reading like? We could have like red to blue. This is where the power effectively comes in, is open circuit. Red to black is open circuit. Black to blue, yeah, so it just reads open circuit, at least on continuity range. We can go to resistance range. That'd be the resistance of my fingers, so I'm having to hold the wires. Red to black, nothing. Black to blue, let's have a look. Nothing. So you can see, guys, I've got the circuit board out. It's all reading open circuit. I mean, looking at the way this is connected, the blue and the red, this is your live and neutral 220 volts coming in. And this obviously is supposed to switch via the relay to the heating element. The heating element's okay, but either the relay isn't good or something on here isn't good. The fact there was a flash and it tripped all the power out makes me think that something on here has gone short. Maybe there's a MOSFET in it or something, and then it's gone open. But because of the way this is constructed with this black hard stuff like resin, epoxy, it's all sealed in there, potted as they call it, and I can't get to it. I can't get at it to see what's on this PCB. I'd imagine there's probably a little bridge rectifier somewhere, because there's a capacitor here. This is a 63 volt capacitor. So my thoughts are the mains power comes in via this capacitor, which effectively is kind of like used as a resistor. It passes AC, but it will drop the voltage maybe to about half or quarter, depending on the value of the capacitor. It's 0.22 microfarad, 250 volt. Other side of this, I'm guessing, is a rectifier diode that charges this capacitor, and then under here is no doubt some sort of circuit that possibly uses this movement sensor to switch the relay on and off. And something in here has happened. Yeah, it's open circuit. I certainly don't have a short circuit heating element, we know that. Okay, so there's nothing we can fix in there. I mean, it's all encapsulated, that board. I wonder if this actually is working though. I mean, the heating element reads okay. That just reads open circuit. I couldn't see any like burn damage or anything there. I wonder if what's happened here is that the power cord on this bit here has had some sort of problem and maybe effectively shorted out. I mean, what I can do, although it'll make the cord a bit short, is cut this off here to take this piece out, so I don't like that. And then we'll see if, yeah, we can get the strain relief. Let's cut this off and let's put the cord back on so much shorter and see if it works. I mean, if it works, I can probably find some of this heat resistance cord from somewhere. So let's do that. In fact, while we're at it, while we cut this, let's have a look inside this as well to see if we can see anything that gives us more of a clue as to what happened to it. So I've stripped back some of this stuff. I'm just interested to see whether or not there was any obvious damage inside here that might have caused a short. I mean, there's a bit of damage there to the earth wire, but I'm not sure if that might have happened when I was actually cutting back this stuff, to be quite honest. And it doesn't appear to go all the way through to the wire anyway, and if something had arced, you'd expect it to be blackened where that had happened. And the same at this end of that sort of stiff part of it. There's no apparent damage to the cable here either. I'm interested just to see what happens if I reconnect it. Just connecting a short wire onto it, probably the safest way. And let's see if it actually does work. Okay, so I've got it back on. The strain relief is attached firmly, the wire's firmly gripped inside there. You can see them all coming through the middle. You can see it might not be quite in focus at that angle, but everything's there. This orange thing behind here, by the way, with two wires going to it, these ones, I figured out that's actually like a little neon indicator or something in there. That's a light. So let's see if this actually works, because I can't see any shorts. We can just check again across the plug. So we're on resistance range. Yeah, and it's reading like 4 megohms, yeah. So let's give it a go. Okay guys, I've got it here. I'm on the mobile phone, because obviously if it trips the power out, you won't see what happens, yeah. So I'm going to plug it in. I've got the power in the office switched off at the moment, so we'll just plug it straight in there, and then I'll switch the trips on. I mean, the idea is, A, I'm at a safe distance. Just get the wife stand between me and the iron. And then we'll switch the power on and see if it trips out. Well, all the power's on, and the orange light is on the iron. Oh, no, there's a green light on top. Right, so it looks like, in actual fact, the thing is working. Yeah, I can smell it now warming up like an iron, so that's good. So, yeah, however, it looks like we've actually got it to work. And I've just unplugged it from the wall and I didn't get a flash and a bang. Okay guys, so that was a bit of a result then, yeah. Apparently now I can have flat clothes again. Which is nice. So, please the wife or girlfriend, apparently they use these things, you can ask, yeah. Maybe some of you guys are multitasking and multi-whatever and you can use one yourselves, okay. I'll leave you with a quick thought. So this is a genuine hotel sign from a Hong Kong hotel in the 90s, and the sign said, in the rooms, it said, "The flattening of the bedclothes with pleasure is the job of the chambermaid." It didn't say if she used one of those for the flattening with pleasure. Anyway, I'll leave you with that thought, guys. Hope you enjoyed the video. Nice and short one, that. Yeah, not too long for me. And I'll see you all soon on another Learning Electronics Repair video. Ciao for now, guys.